We can start now. We are ready to start this session linked to the some of the topics of working group 1. We start with a brief introduction of the session made by Andreas. And after we will share in a different group to discuss about some relevant issues.
Very well. This is just a little collation of some thoughts I wanted to present up front to stimulate hopefully a good discussion afterwards in the breakout groups. So what really is the ultimate goal, I believe, is that other people are confident to use your data. And probably one of the good examples of a paper I've read about this is that is a no-die sensor about trust and data quality, and these issues have been addressed. And what it comes down to is know your sensor. And based on this, everything else will sort of follow. Now, when I look at the data flow and the influencing parameters, so we go like from this target of an instrument to some pre-processing analysis and the results. I mean, that's sort of pretty standard. What is influencing, and I'm not saying this list is complete, but what you should bear in mind is that you've got the current state of the target. This might vary over time. There's the sun angles to be considered. The atmosphere is changing, temperature is changing. There's a BRDF property to these targets. So practically, this BRDF will then influence what your instrument sees. So the instrument is governed by center wavelengths, full WSF maximum, or if you want to be more specific, the spectral response function, the signal to noise ratio, the field of view, the sensor angles, the deficiencies of these instruments, because they are never what the blueprint says, and the calibration. And all these factors have an effect on the spectral data you're getting here. And then you move into data pre-processing. And here you try to correct for instrument artifacts. You might convert from irradiance to reflectance factors. And I believe there's also instrument-specific algorithms being used. And then you move on to higher-level algorithms. So here a few critical thoughts about this. You can see here metadata is all over the place. So the question is, what information do we need if you want to replicate the target state? Then, do we really understand the instrument? Can you replicate the measurement setup? Are there protocols and have they been applied? Other thing, how can we compare instrument derived data? Because the field of view and the spectral response function practically govern the sampling process, and that means that if you try to compare the different instruments, or you get products based on different instruments, they will be different. And how to compare these, I guess that's quite hard, but it's also important to realize that maybe you shouldn't just try without thinking it through. Data pre-processing, do we reinvent the wheel? I sometimes think we do a lot. Every second person I talk to has written their own algorithm to remove jumps in ISD data, things like that. It's a fact, and question is, are these comparable? And are the resulting data comparable? And then you move on to data analysis, and this is probably, well, are these algorithms generic? You write one, you write a paper about it, and then it's lost somewhere in a cupboard. And will it work on other study sites? I mean, practically you're not going to get any merits if you can apply to another study site. The peer review of writing a paper is not really supportive of this, but it should be generic. And have you got a physical explanation as to why your algorithm works? And I think key to this is just a multidimensional problem. And key to this is, as Jean-Luc pointed out, the physical models that just have a virtual reality where you can fix certain constraints and then compare between instruments. This is one way how to move forward if you are lost in the multidimensionality. And then maybe uncertainty. So there's uncertainty all over the place. Your target is changing over time. Maybe uncertainty in your field protocol is really what, if you measure a measurand as in your field protocol, is there an uncertainty involved due to this? Radiometric uncertainty, I just want to mention, if you do radiometry with a traditional field instrument, I would believe that uncertainties of 4 to 5% are just a fact. Then, well, if you do a calibration to, for example, reference, what are the uncertainties of these references you're calibrating to? When have you last cleaned your spectron panel? When has it been tied to a national standard? And then what are the uncertainties of the algorithm? So practically all it sums up to is the need for uncertainty propagation all the way up to your results, and then the traceability from your results all the way back essentially to the original data. So here's a questions that might need answering. So what are the core metadata for the target and environment? What are the core metadata for instruments and the sampling setup? Then what is maybe the shared common community knowledge about instrument pre-processing? Everyone reinvents the wheel, so one day is there a need for a forum here? Biggest question for me is, what do end users want? This is, think about the case when you are not the producer and the consumer of your data. It should be someone captures the data for you and you are going to use it. So what are you wanting if you wouldn't have captured your own data? And what should be stored? Do you want the whole chain of processing all the way from the raw data up to whatever level? And what metadata are required? And then I'll put it in a spectral database. It's a bit overlapping with these processes. If you consider this as an information system, what questions do you pose to this system? What answers are you looking for? And this will essentially define the capability of such a system. Currently, I would say a spectral database is as good as the metadata you put into it. We can store anything almost. However, the way you interrogate such a system is a matter of clever interfaces as well. And we need to know what do the end user want this system for. So that was my part. Maybe, John, you want to add a few provocative thoughts?
I don't know if I can be provocative at this point after lunch, but yeah, I think sort of to some of the same things, but maybe add a different way of saying it. You know, we've been hearing lots of presentations, and this community for years have been coming to meetings where we discuss really interesting science results. I call a lot of this backyard science because a lot of the examples are, you know, research done here, research done there. And the remaining question really is, what are the universal things that we can draw from this? And how can we get to the point where we can, you know, really draw universal conclusions? You know, so part of this is the tools, obviously some of the tools that we're discussing here, databases, metadata, protocols. But there's really some fundamental issues that we have to address if we're going to get there. And you know, obviously reuse of existing tools, intelligent reuse of existing tools is a good idea. The idea of making use of Specio, for example, rather than each of us having our separate databases, I think is a really good example. But you know, to reach Suresh's goal of, if we're to be able to interact with Oak Ridge in a meaningful way, if that's an example of where we want to be, we have quite a bit of work to do to be able to get there, I think. So how do we get there is really the question for this discussion. And I guess, you know, there's two approaches as we've discussed. You know, there's a sort of top-down, you know, somebody determines how you do it. I think that only works if you're going to fund everybody to do it that way. What I've seen is, unless you give everybody money and say they have to follow that, they're going to go do what they're going to do. And part of that is good because it's innovative and it brings in fresh ideas and uses new technology. So the reality of the world is there's always this bubbling up from the bottom, you know, the grassroots approach to solving these things, which I think is in a way more challenging, but also very exciting if we can capture that energy and innovation. And it's a little hard to see how to get to the universal approach that way. But, you know, can we do it that way, I guess is the question. Those are just some thoughts, just repeating things that people have said over the meeting, I think, or trying to summarize some key points. I guess things to think about in this discussion. You want to say anything, add anything? Or
I would like just to add some I was thinking to the fact that there is a lot of databases we saw in this presentation. Okay. I was thinking to the availability of different database from a spectral ecosystem and from MODIS data, and thinking to Eurospec, I would like also to try to think which is the best way to make visible our cost action, Eurospec cost action, and how we can keep in touch with the other database. What is what real we can provide, and which is the accuracy of data as and certainly as Andreas said. So in my opinion, we must also think for the next future to develop some common routine and also make available for our Eurospec central database that could be implemented by Specchio or to other communities, as for instance ICOS community. Okay, that's my point of view. Pilar, do you want to add some things related to working group 1?
Well, yeah, in working group 1, we have a very ambitious objectives because we want to build a network and we want to produce standards for protocols and data sharing and data policy, so a lot of things to do. I think, in my opinion, we should try to start from simple things and then to try to build more sophisticated things. So I completely agree with John that we better use things that are already built, like Specure, for example, or the capabilities that are already available for MODIS data and data subset, and trying to put everything together, or not put everything together in the same place, but make it available in a more easy way. For example, when I go to MODIS data, I would like to have the opportunity to have Landsat data at the same time in the same place where I have the subset of MODIS. It would be great to have the Landsat scene of the same place. So I think that kind of things will help a lot in these first steps, because I think it's quite complicated to try to go to more ambitious plans, but it's only a personal opinion about that.
As I said before, in my talk yesterday, Eurospec, in the perspective of Eurospec, we have to act as a sort of bridge between different communities. So I think that by the end of our project, so in 20 months or something like this, we should be able to provide a product which is a sort of dissemination product, which is able to reach other communities. I said that Eurospec is a sort of bridge between the remote sensing, the flux community, and the optical sampling community. This product should be able to give us some visibility. And of course, we have to get this visibility, putting some data in this and making them available. Of course, at the very beginning, it won't be a huge archive, but what we could do is try to put some data sets, collect some data sets from our network for continuous measurements, and try to provide a tool for data visualization and to reach a big audience. That's my point of view. And then when we will start this for 3 sites, for instance, we will meet other problems, and we will there will be more questions, and we will have to try to give some new answers. So for instance, I find that the data archive, the DAAC, is a clear example of how you can provide data in a very user-friendly way to a wide community, which is not only the remote sensing community. Even if you don't know much about MODIS, you can just download an MDVI series. So if you are an ecophysiologist, you can just make use of this information without knowing much about all the story which is beyond this data. So in my view, we need to provide, of course, information and detailed metadata for quality check, but at the same time we need to be user-friendly for other communities, so they can check data quality, they can check what all the specifications are for our instruments, but at the same time somebody else who is coming from another community can just make use of our data.
It works? Yeah, I have a few comments on that. I think Eurospec is thinking of spectral activity and FluxNet, for example, and flux data. For example, me, I think that all of this community have their historical background, which makes that the data base cannot be merged, I don't think, or up to a certain point, but cannot be really merged because, for example, only in ICOS, which is much more, let's say, homogeneous than the spectral data with flux data, there is impossibility to really merge everything because after you arrive to problem with the metadata information, with problem in vocabulary and literature. There is a lot of, and you want to be interoperable with a lot of things, a lot of different other also global networks. So for example, it's out of question for the atmospheric part of ICOS to change his way to deal with the data format, to homogenize it with the ecosystem part because they want to stay as it is the standard of international Go database. So everybody has integration, but also a background of international and global database. So I think the point is not really to merge the database, but to make the products interoperable. And for example, a way that it is, the DAC product of Modi's subset, for example, me as a FluxNet, as a Flux person, it's exactly what I need because I push very easily. I have a product that is directly the most interesting for me, time series of life of 7 years or time series of GPP. I don't know how to manage GeoTIFF and this stuff because it's not my world. So I have directly a time series, which is the stuff that I'm going to compare, of course, besides. So this is exactly, I think, what we need. Because it's also if the spectral database enter in ICOS, I mean in ICOS it's flux, continuous measurement, whatever is a component of with half an hour basically time step, and plus other stuff which are more periodic measurement, what is live, whatever estimation of biomass by whatever technique, but all of this, it can be constructed time series, periodic, not steppy, but one measurement every 2 months or whatever, but so it's integrated quite well. The spectral stuff is totally different. You are not going, so you can think to, for example, follow your own logic, because this is a bad logic for the quality of data, for traceability and so on, in Specure or whatever, and then from that you can extract, for example, a number of products from that. For example, you can think, okay, because for example, the system that Pilar is installed right now at our site, I talk about that because I know. You have this cycle of 20x minutes or whatever, maybe half an hour, maybe 15 minutes to make a round or whatever. But after to merge it with our database, it will be very nice. Is whatever is the Specure, whatever stuff, but the continuous measurement that there is a tool. Automatically, you extract from your data with quality flag and so on. You extract half-hourly estimate for the typical indexes that are used by people, and that can be merged very easily to the other, and you don't have to merge everything. So I mean, the point is that each database has its own logic, and I think need to go on with that because there is also international community. It's not like, we decide that, but we can change. You know, it's not the case. There is some very good reason from a lot of scientists. So for me, the main point is to have a good interoperability, and then you enter in metadata. Also, I don't think metadata for outside community, for me, can provide me 1,000 flag about Modi stuff, but I'm not able to understand it. People using the flux that we produce, GPPs, I don't even know that GPP sometimes is not measured. I don't care about if it's neural network or what is the graphic technique, even if somebody that knows is very interested in. So also in the metadata to put all of the, to a certain point, but at a level of detail, I will not, because you are not able to critique, you don't know what to do with that information. Yeah, it's my point of view.
But the metadata really need to be extensive. The thing is that then you use a tool, and with that tool, you just filter the metadata and you look at the part that you are interested on. But your interest and the interest of another person may be different. So it is important that the metadata be really very extensive. Then you have a tool in order to filter that information.
I was not saying that metadata should be short. I think metadata that go with the interoperability products should be not too complex because it's useless. Of course, the metadata of Kyoto or the one of ICOS is going to be as extensive as possible, of course. But when you transfer a product outside to be merged for interoperability purpose, well, you don't need to transfer the full events of the metadata. There are metadata, because now, okay, there is for common data format, it's easy with the NetCDF. People for big project aim at that. But now there is also FP7 project, I don't know from who or whatever, because there are so much communities that work on metadata, also common format. So we'll see what happens. Also, we are not alone on the earth and for interoperability. But I think the great point is each one, my point of view on that is that it's just from ECOS, which are quite similar stuff, that is basically not really very relevant to merge really too much the database and homogenize too much. You have each one have his logic and have very good reason to defend that. So after the really point is how you make them interoperable with convenient tool. And I think effectively the DAC stuff, because for example, for FluxNet is not really operable because they cannot control the way it calculates GPP. Each flux is different. As John say, if you don't pay people to do that, they do in a different way. And FluxNet data, I don't know nobody that have used FluxNet data. FluxNet data submitted voluntarily by people. After in FluxNet, there was a FluxNet Latwil dataset production that was used a lot. But the FluxNet data, I don't know nobody that, because of that. So I think really the point will be each one should develop his own logic, but thinking on interoperability, common data format, and these kind of things.
I have a question for the audience, and it follows on the discussion that we're just having. We're all talking about interoperability. I think we agree that that's a worthy goal. So my question is, what degree of interoperability are we really talking about? And it's partly a question for Suresh. In other words, my impression, and you can correct me if I'm wrong, is historically Oak Ridge is not really in the business of interoperability. It's more in the business of archiving and serving back to the community. So this goal of interoperability is not necessarily going to be provided by the data archive centers. It's up to the community, I think, to define it. So what is the degree of interoperability we're talking about? Are we talking about something where you and I can exchange data, and we have to call each other on the phone, but we can understand each other's data? Or are we talking about something, a flexible database environment or a cloud-based solution where we have the right searching tools, and with the right metadata, we can find data and make sense out of data? Because there's a wide range of ways of defining that, and I guess I'm kind of curious what people feel the needs are within this community. So that's my question for the audience, is what degree of interoperability?
I'd like to quickly comment on the aspect of interoperability. I mean, when the DACs first began, the idea, like John said, was to basically get data. Just get the data, set up some systems where we have a metadata editor. This was created back in 1996. When metadata was not even a popular concept. We created our own tool because there were not any open source solution out there. So we created all those tags and all this sort of stuff. But at that point of time, there was no standards that existed. So when we created it, we went with our own standard. And now after 20 years, we're realizing that, that's actually bad. I mean, now we're trying to find out that, all these catalogs, we're trying to search for our data. We need to adapt our metadata to those new standards. So I wish there was that standard that existed before. So in our next version of our editor, what we're trying to look at is to maybe adopt an ISO standard or something like that. So basically go with the standard. And I think the key over there is that the standards keep changing. The technologies change, and we're constantly improving. But the good thing about putting everything into that standard right now and making it interoperable is that 5 years down the road, if there's something new, it's much more easier to transfer that information, whether it's metadata, whether it's actually data. It's easier to transfer it into an existing format if that data was following a standard. Like one example that I give to several different people is, we had this data file which was written in a Fortran code. It's like 500 KB. In 1996, they wrote their own compression to actually compress that data to 300 kilobytes. Right now, 500 KB is nothing. I mean, I could get that on, it's such a simple, I could get it on my camera. It's so simple. But if the data was actually stored in a JOTIF format or so, in 20 years, it's easy for me to convert it. But I'm finding it hard to go in and convert that Fortran code. So kind of going back to the concept of interoperability, the data access is important. We got into the business of interoperability because our data users are grabbing data from multiple sources. They're spending a whole lot of time going to each one of those data centers, grabbing the data, doing a lot of data preparation, and our research has grown to an extent where we're grabbing information, as much information as possible to do our science. So it's really important for us to actually set up our data for interoperability. And there are many different approaches to it. I mean, I don't think so there's one approach even with standards or interoperability. I think if you go to a GIS person, they'll say, go with OGC. You know, that's the format that I want. But if there's somebody else who's actually working with maybe point data, they'll come in and say, you know, maybe I would like to use REST, you know, but I don't care. I mean, whatever standard that you use, as long as I'm able to bring in all the data without having to have an intrinsic understanding about how to go grab it, that's actually fine. And presentation layer is very important. Try to avoid all this complexity. I mean, I think for certain research categories, you know, it may not be necessary to kind of talk about all these, you know, like Loris said, that, you know, there's all this higher level stuff which actually goes on. I don't care about it. You know, just give me the data, and, you know, in a presentation layer, which is actually important, and that's really critical to understand. I think, who's your community? How do you want to present that data to your community? And there's also this 80-20 rule. I mean, you don't have to build a system which is multi-million-dollar for 20% of your users. Build a cheap enough system for 80% of your users and make sure that that 80% of the users are satisfied with what they've got, and be able to do that. So I'm not sure if I answered the question. It's more of background information, but I'm interested from the community of data providers as to what's the interoperability that they would be interested in dealing with.
But I think to complete and a little bit to answer to what level of interoperability, I think the example of, I don't know, it has worked for this subset modis for FluxNet, but 3 years ago, I think it was 3 or 4 years ago, that I received an email, please check your coordinate, we are going to produce some standardized stuff and stuff like that. I just check coordinate of the site. And then 2 years later, I say, now there is a last collection of modis 51 stuff that is available for the site and so on. And I can use it very directly. So I think that came also, it has to be seen that here there was probably a need from some people, Flux Towers, that doesn't know how to deal with metadata, and then this product is used, and it makes sense to make interoperability there, and maybe, but you don't have to think in an absolute way. You have, I think it has to be case by case. This community is interested in this part, so this part should be made available for this one. The others, I will not care. More or less, we know where it is going. So I think there is the level of interoperability is first seeing the clients in where there is some synergy between the community, what can need a community from another, what kind of data, etc.
One of the things that we've been discussing up here is there is another group that's having a very similar discussion in Australia at the Australian Centre for Ecological Analysis and Synthesis, and they had a meeting on spectral data, but the theme was bio-optical measurements, which is in a sense broader, a little broader than the theme here perhaps, but there was a lot of very similar discussion, and that group is in the process of making some conclusions, and it hasn't really reached its conclusions because it's an ongoing working group. And but Andreas and I were at that meeting, and they're very interested in providing information to this community when they're ready to do that, but they're also very interested in what conclusions we have that they can take home too. So they're waiting to hear from us on what our conclusions are. And so one of the things we thought would be worth doing would be to ask you guys to come up with some conclusions on these questions of you know, the theme of today. I don't know if we're ready to do that yet, or but
I didn't do anything, any conclusions. So we can at the moment we can start to discuss in metadata, and after each group reports its activity, its list of variables, and we can make the common conclusions.
okay, you want to?
Yeah. If you agree, now we can start to discuss on metadata, and we can share in 4-5 groups, and each group can try to list which is the most important information that can be included in this metadata for hyperspectral continuous measurements, and after that each group can report this list. We can try to discuss and make the conclusion of the session and of the meeting, the discussion. Okay?
Yeah, but as far as I understood this morning, there are out there some libraries already with metadata. So why we do not compare a bit what they are doing also? Why we don't start by looking at what it exists?
Well, Manuela, you have a slide of Milton, right?
Yeah.
Which is a good reference.
Yeah, there is from a paper of Milton et al. 2007 on remote sensing of environment. There is the table 1 that reports the typical metadata required for hyperspectral library or sampling measurements. And in fact, we can refer to this metadata description, but as we discussed also yesterday in the meeting, sometime requirement for optical that we must include in the metadata is dependent of ecosystem characteristics. So it could be nice to discuss and to try to think to metadata for forest ecosystem, for doing optical sampling, or also leaf area index and FPAR measurements for scrubland, and for also for grassland and croplands. So in this table, there is a lot of information that, in fact, we have in ICOS Carbon Europe database, where there is all information linked to the location of the sites, description of the sites. In my point of view, we don't need to request this information to PI, because we can take this metadata from ICOS portal, but we need to know which is the time resolution of the measurements, and sky condition, instrumental setup, and also all things related to in situ measurements. In my and another important issue is to know which is the radiometric which is the variable that is measured in optical samplings, if there is radiance measurements or reflectance measurement. I think this part of description of metadata is also strictly linked to the protocol. So to the protocol that we can try to suggest for doing a good optical sampling. So right now there is, as you know, there is no a protocol, but if we can use this table, and but I'm sure that if we don't give some guidelines to people that give optical continuous measurements, there will be some missing important it could be that we miss some important information that can be used to elaborate and to understand the data. That's
Yeah, so to sort of reiterate, we do have these existing examples. This is a really good one. And I guess a good question is this the right list? What's missing? Is a question of just adding to this or working from this, or is there something fundamental that's not on this list that we have to think about in the issue of metadata when we're talking about optical and flux data? And what would that missing thing be? I think
just to add to that list of missing things, the very first thing that we have in this list is location, and very often what we find is there is no precision associated with that, and I think that'll be important to capture. That it's actually important for us to. 40, minus 110. That isn't correct for us. You need to have very good precision, and I have at least a minimum set of what the precision should be. I have it at least up to 3 or 4 decimal places, because especially for this kind of a research where we're comparing field data with satellite data, that's going to be important. And that's the only one that I'm intimately familiar with, but there could be similar things for the rest of the list, but I just wanted to add it to that.
Yeah, that's a really great example of what's missing. Around most of these things, some quantitative error or precision or some measurement of how well do we know that value is really a critical concept for some purposes, and so I think that's a great example.
There is also the problem linked to the time of the measurements, which is the right time. How we can really have all tower with the same, all system with the same time. Can we use an web site to have at the same time? That could be an idea. Generally, ecosystem covariant flux are connected for remote control. So just by logging clock control, we can sure to have we are sure to have exactly the same time at all sites.
I don't know, it's the first time I am in a meeting like this, so I'm a little from outside, but I have the feeling that we are discussing the details without having a clear idea about the fundamental things. So maybe the metadata for me is just a technical issue that will depend on the circumstances and things like that, but for me it's more fundamental why we want to add optical measurements to the flux towers. What is the reason for that? It's just to measure the phenology. Because it's for phenology, then there are one thing. It's just to characterize the footprint around the tower. Then or it's just that we want to measure some biophysical parameters from the optical data that can help the interpretation of the fluxes. But it's not clear for me the reason. If I will be running one tower, and you came to me and say, I want to put one optical instrument in your tower, I would say, why? And it's not clear for me in the discussion that we are going into the details of the metadata, which is okay, but I am missing the fundamental reasons for having the optical instruments in the towers and not somewhere else, for instance. So why we don't put a network of optical instruments which is completely disconnected from the flux net? So why we want to, I know the reason, but I'm trying to be provocative. Why we want to put optical instruments in the tower? And then if there is a reason, then we should discuss if this is just for phenology, maybe just 2 bands and NDVI kind of things enough. But then there is no coordinate because it will be in the tower and it will be looking all the time to the same place. Now, if we want to characterize the footprint, then we probably will need something around like MODIS kind of thing, so we have an idea what is going on around the tower. But is this just for maybe get, I don't know, variability in chlorophyll content or water content? There's another type of measurements and another protocols, another metadata. So it's already clear what is the purpose of linking the optical measurements on the flux tower and what is the final objective of that? Sorry for the question, but
it's a very good question, and I think that's, I was kind of hoping someone would say this, because usually when we think of metadata, we are thinking at this level, and this is critical. It's usually about the instrument, or it's about the field methods, or maybe it's about the calibration of the instrument or the protocols for the field method. That's what we often think of. But, you know, the description of why you're doing it is part of what has to be there too, for a couple reasons. You know, so much of this depends on why you're doing it, and if we get down to this level without answering your question, it sometimes seems like a meaningless exercise. It can have more meaning if that's well defined. You know, my own perspective on your question is, you know, there's a couple of pretty basic reasons why we're talking about doing this. You know, there's a real challenge between, you know, in terms of connecting satellite data to flux towers, because they sample differently. So the purpose of, one example of the purpose of doing this is to make an explicit link between what the flux tower sees and what you can do with remote sensing. It provides the glue. And then the devil is in the details. How you do that can get quite complex and get into a whole lot of issues. You can think of that as a satellite validation issue, but I think it's much more than that. It's if you're going to upscale and using a model, there's a bunch of questions about how you do that. It depends on your model, but also how you use your data. And I think having measurements in time using optical sensors in the footprint of the flux tower that also measures in time enables us to ask that question and improve our models and improve the upscaling. And so those are some answers to your question. There's other answers too, and maybe, but you know, that's actually, I think, a really good point. You know, our intention, I think, in part was to get a discussion going here, but I'm personally interested in doing what Manuela suggested, which is at some point we break apart and have you guys discuss these in small groups and see what comes out of that. Do we all reach agreement on these questions, or do we have 5 different answers if we have 5 different groups? So metadata is partly instruments and field protocols. It's also the why we do it, and it's also what we do to our data, the processing of the data, as Andreas was saying. So we can take it at all these levels.
I wanted just to add, because in the way I presented ECOS, I wanted to state not exactly the same stuff, but something like that the first stuff that is expected from ECOS is first, and it's linked also to the variable definition. What you should measure at flux site, and then why. It goes obviously in the same direction. So the first recommendation, before expecting details that can go, even if they are very important, I think, as I told, the ICOS community is why we should do that. All people ask that. Half of the people, they ask that. So of course we can see, and the answer can come from that community. Of course for you, John, it's common. If you are not convinced of that, you are, let's say for me, the father of Specnet. Specnet is linking. So why? But this case have to be made at the outside community, I think. So I think for you, it's maybe clear, the answer, but for many people it's not clear, and for ICOS, for example, it's not clear at all.
Coming back to this issue of the metadata and everything, I agree that maybe we are talking about a very detailed and technical stuff, because in example, I think we should separate what is optical sampling from continuous optical sampling. I think it's not the same going to the field with a spectrophotometer, working for a couple of hours and go back home, and it's not the same that having an instrument in the field for during the night and in the day and under different weather conditions and keep it working all the time. So I mean, we should think about the details in different for different cases. But maybe I think we should start maybe for a point. If we want to gather data and we want to use them together, maybe we should try to set a kind of minimum requirements for data. In example, Charles was talking about the location of the. So in example, we may not be interested in data if they are not located. We may not be interested in data if they don't meet a kind of minimal requirements, so that they are all comparable, or we can merge them. So maybe that would be a starting point. No? We must ask the people who want to upload the data that they have meet some requirements, maybe not very deep or very hard to meet, but at least a minimum set of requirements. And maybe we in smaller groups, more technical groups, we could try to develop that kind of requirements, and that would be a starting point. Because I mean, I don't know. I mean, I don't know. Maybe we can say, okay, we want all the data, and then we will see what can we do with them. So I mean, that would be another option. I'm just setting the statement, not the question.
Maybe I can express my concern in a different way, because before I was maybe too provocative. What I was trying to say is that before coming to the details, because the details will depend very much on the type of instrument and other things, as I see the story, to be successful, we had to make the case in a way that for people working more on optical data, we take advantage of the fact that the flux towers provide additional information. So for instance, for the remote sensing people, we can say that putting our instruments in the towers makes sense because we will benefit from that. And at the same time, for the people running the towers, they should see that the fact that they have an additional optical sensor there will help them in interpreting the data or getting something more than just having another instrument just in the tower. And I think this was the point that was not very clear for me, because we are talking about the optical sensors, but it's different if you say continuous measurements or spatially distributed inputs or scanning systems or imaging systems or and I think before coming to the details of exactly what kind of instruments should be put there, maybe we have to make the case what is what we want to get from our instruments put in the tower, and what kind of things will be useful for the tower people to get this additional data. Because albedo, they already have albedo. NDVI, you can get NDVI, but I don't know if NDVI will be very useful for the tower. So I can imagine that some imaging system describing what is going on in the footprint will be very useful. But I think this discussion is missing. And until we have very clear idea what is the objective of that, then we can go to the details. But it's difficult for me to go to the details exactly what kind of metadata we have to put in the database without knowing for which purpose we are doing this.
Yeah, I see here that we have three elements in this database issue. We have the technical element, which is has been solved in some examples like Specnet or GeoChronos, so I think you guys can deal with that. And we have the users and the data providers, and those elements are the union of these two elements are metadata, because once the data providers we need to know from the data providers which data they can provide. So we can draw a metadata with a lot of information, but finally the data provider has some specific data that can provide. So we should try to define a minimum metadata. I don't know if you, Andreas, could have explored that in your databases, because you have already some experience on that. And we can even ask to the Eurospec community about that. So maybe we can use these metadata examples as a reference, this one from Milton, distribute within the Eurospec community and see first if there is something that is not in this metadata that we want to add, and then what information from that metadata are we able to provide. And then from the user's perspective, we need to know how are they going to use the data, because we have the FluxNet people, we have the remote sensing people, we have the modelers that are also interested in this kind of data. So this is a complex problem that maybe we can try to approach using the same methodology that we use with this paper that we wrote in Working Group 1. So using an online survey to know what people have, what people need, and how can we put this together in a database that could be useful for everyone.
For instance, during the meeting of a working group 4 in Jena last year, we discussed about the requirement from the modeling community, and in fact they need a lot of data, a lot of ancillary information to run and to parameterize the model. And regarding the specific information linked to optical sampling, they need the all their need is mainly driven by which type of the model they use, which is the objective, if is an upscaling, is a regional scaling, and so it was really difficult to draft which is the most common variable that they need. So the best, in my point of view, the best solution is try to summarize the most important variable that we can provide by optical sampling. And okay, in the future, also modeling community or eddy covariance community, they can and ask us more detail or more information that maybe will be ready to provide, because it's really difficult right now to think of all requirements for needed for models, for eddy covariance community, for other users.
I think it's difficult to sit and think about what are the needs of potential users. What is really important is to have the metadata that make our measurements comparable. So that if I need to, I don't know, do a synthesis work, I can look into the database, see which instrument was used, when the measurement was taken, if a special methodology was applied, and that I can see which measurements I can use, which measurements I can trust, and which measurements are comparable. And then to go back to Jose, if we, our question is to either build a new network or use FluxNet as a base network. We should build a new network because FluxNet is biased. Like eddy covariance technique is a technique that is working under specific conditions. So like the development of FluxNet is really affected by this. Like it wasn't planned from top down, so it means that the representativity now it's okay, but it's like by chance that it's like that. But on the other side of the coin is that we have a great opportunity for validating remote sensing products. So like we are living in a era where remote sensing is becoming more important, but remote sensing by itself is not working. We need to see what is there, what is the truth. And having combined eddy covariance and spectral sensing is a great opportunity for validating remote sensing products. And then we can go from point studies to regional studies to global studies. That's why it's really important to have spectral measurements at FluxNet sites.
I like this discussion and these comments. Yeah, I would argue that validating remote sensing is really important. And backing up a little bit, while I think addressing what the modelers need is a good idea. I don't think that should be our primary goal. I think the idea of interoperability or comparability is quite important. So among the community of people who make optical measurements for the purposes of assessing flux, can we get to that point of interoperability? A couple of considerations. I mean, there's parts of the world where we really can't get good remote sensing of the ground. And there, I think, field optical measurements become the only way to really know what the surface is doing. I'm talking about the Arctic and the tropics. And if you look at, you know, the map of distribution of these measurements, there's some pretty serious gaps there. So I think getting a set of clear approaches to doing this and getting this in enough of these places in the world, I think would answer Jose's question for the community of why do we do this. It hasn't quite sunk into the remote sensing or flux community or the world out there why this is important, because I think the data have not yet been adequately demonstrated. But when you start to compare what you measure on the ground to what the satellites measure, you sometimes get beautiful relationships, and sometimes in these parts of the world where it's hard to do, you really see the importance of the ground optical measurements. I would argue it's the only way to get the surface reflectance or albedo. So, you know, this goal of comparability, so we have a universal kind of approach to these things. So we have a method that works for the whole world. Whether you want to think of that as validation or valuable in its own right, I would say that's an important goal. That brings up the question of how do we get to absolute reflectance, or do we need to? I think we need to, perhaps, because when you think about what we do, we're measuring something often that we're calling reflectance, but there's a lot of issues with comparing these measurements, because, you know, panel calibrations, angular issues, degradation of the panels. You know, if we really think about it, that's a pretty high bar to get to that true intercomparability. So how much, you know, how good does that have to be useful, I guess, is kind of the question. But I think the mark, the place where we want to be as a community is absolute reflectance defined according to some definition of reflectance. And I don't think we're there yet. So I think this kind of discussion, it can be kind of frustrating because it seems like we're going nowhere, but I would say this is the process of educating ourselves in the community about what do we need to think about to improve the science to get to these goals. And so I find it a really interesting process, and I think we can learn a lot from these discussions. Some really good points coming up here. Jose, you were going to say something, I think.
I don't want to appear like the one which is against these things. Actually, my really concern is that this discussion is going for more than 20 years. And I remember the first meeting where we discussed things like that was maybe around 1990. At that time, the idea was to put some instruments in what they called anchor stations, which were meteorological stations where they have complete fluxes of sensible heat and latent heat and things like that. At that time, nobody was interested in carbon. Carbon came later on. But still, there was evapotranspiration. And there was already the discussion that you can add optical instruments to help getting something that will improve the surface energy balance at that time. When the carbon came into the play, then the discussion moved to the carbon. So what I'm trying to say is that this is something going on for a long time. I think the discussion now with the carbon community is much better because we are very close. The problems we are dealing in optical remote sensing and the problems they are dealing in the carbon community are really very similar, much more similar than the problems we discussed before with evapotranspiration or other problems. So we are really getting close. And I think if we really make the case that I see the point that we need validation sites, and the most obvious way to go is to take the FlashNet sites because they are already there. So even though they are not the optimal places, some of them, for validation or remote sensing, because they are, like you said before, are not that within ICOS there are people saying that this is not the optimal way because they are not. I know in remote sensing there are people saying no, it's not good to put sensors in the towers because around the towers the situation is somehow contaminated by the tower, so it's not really the dynamics that you want to see. So you have to put your sensor somewhere far away from the tower. So there are discussions going on, but to be pragmatic, I think linking the activities of FluxNet or the towers and the validation of remote sensing and the improvement in the models, but even though there is a lot of confusion, still there are some key variables that are needed by the modelers. And I think we can provide this from optical data. So if we manage to put the three pieces together, the need from the remote sensing community, the need from the towers, and the need from modelers, or not really doing remote sensing, but just optical measurements, I think we can really make the case. The question is that we have to be very careful on addressing properly the problems and came to a very simple solution that could be, for instance, reflectances in just few bands, but well calibrated, stable over time, have some reference calibration somehow, to get something that is convincing for outside people. Because if we saw this presentation with spectra that looks very noisy, in some cases clearly wrong spectra, will be hard to make the case that they should use this data because the data looks very noisy. So we have to give the impression to the outside community that we don't have the perfect data, but the quality we have achieved is good enough to really use the data in models or in other applications. I think the same is true with the Flux data. I mean, now we all believe that the data is already good enough to use the data for models or other things. And all the communities are, I mean, the same is true for remote sensing. Now with the calibration of the satellites is much better, and now we can provide much better products than before. So we really are in the point where the three communities at least can really work together. And if we find the way, I think we can make the case. But we should not get lost in the details of if we had to put this metadata here or not. For me, the metadata is something that is a secondary problem because I think Arnaud also said that before. If they want to use data from remote sensing, they will not look at the metadata because the metadata is something which is explaining the data. But I want to see what is the information content. Then if I have some problems, then I will look in the metadata, but I will not, from the very beginning, look at the metadata. So the metadata should come later on. There will be some information there which is meaningful for the other communities, and then the metadata and the details and explanation of the protocols and things like that, this is something that can be elaborated later on. So I was trying to say that we should not do before the details and then think about the general objectives, but do the other way around.
Yeah, I quite agree with what Jose said, and I wanted to add that for ICOS, from my experience, for example, of use of data, monitoring people making models, for example, basically they download your data because I have quite experience with as data provider of the data use, and 2% of the people ask you something about the quality of your data or whatever, as a great maximum. People now in models they use data plus uncertainty. Now they would like to have uncertainty on the data. But the way I've been collected, they have to refer to a standard in order that they know that it's comparable. So if they have something that MODIS, for me, it's okay. If somebody wants to discuss MODIS, he can discuss it. I have said MODIS is explained very well somewhere. So generally, and when you are within a community, when you want this detail, generally you go directly to the source. If I'm interested in what I've been Jose there, I have a phone call, and at the end of the story, if it's well, and you go to the source, and it's the best way. No any metadata can do as a data provider can explain to you. And also I wanted to, because I fully agree also, and this is a discussion in ICOS, and we are a few, and I'm of this one, that pretends that ICOS should only do what is able to do very well, and not going in stuff which are dangerous and which are seen from outside, it can be seen as a failure for ICOS. So we should go, and quite a number of people, that stuff that we know we are able to do with high level of quality and standardization. So it's much better to provide 5 or whatever it is we are able to provide, but in a rather robust way for long term, because if after they can say, no, but look, because they say they do blah, blah, it's high quality, but look at this I know and this is a shit. So this will be a very bad message also and very bad strategy for ICOS. So also, and after the stuff can be inclusive. If in 10 years there is a technology to have multi-angular, very precise stuff, automated calibration, spectatron, auto-wash stuff with maybe. But now I think for ICOS have to ingest stuff which are really very defensible in terms of standardization and long-term stability. If the accuracy is, as I said before also, depending on what you need, or what you say, maybe you, John, that it really depends on what the use you are going to do the stuff of the accuracy levels that you need. So for example, for NDVI, you don't probably need, if its main point is the phenology, it's probably but really try to think about ICOs that I know, and for inclusion, first do stuff that works good, and not, if you begin to present that, it's not good strategically.
So I guess I have a question in response to what you say for the Eurospec folks here. How do you see this? Is this discussion primarily geared towards ICOS? Is that the objective or a main objective, or really is it a side objective, and you know?
Well, I would say that it's a very important objective because ICOS is a long-term infrastructure mainly, but I have seen presenting the Eurospec activities, and in particular this link with ICOS, to different scientific communities at meetings. I realized that also the remote sensing community is really interested, because he's realizing how he's realizing the potential of these instruments for calibration and validation activities. So I think also another question we should answer is, if we had a tool, let's say in a few months, which is able to upload data and share data and make them visible to the communities, would we really be happy to share this data? I think we should share this data, and at least find out a few sites where we can start from, basically. So I would say that we should start. We should make a priority for continuous measurements, and put both hyperspectral and multispectral. So we should go for fluxness sites and possibly ICOS sites, just as an exercise for ourselves to see what the problems are, but also as a dissemination tool, and to attract, as Jose was saying before, different communities. So I think that in this work we are going to start now, I mean, the objective, one of the main objectives should be, okay, let's put a time series of continuous data for 3 sites, 4 sites. Then we will see within the community who is willing to share data, but I think at least we should make them visible, and then potentially people can upload this data and use them. Just it depends on the data sharing policy, but at least we should make them visible. I mean, just the trend of the graph, and then if people think that this is interesting, they can knock our door, and then let's see what happens. But we need to be visible. That's the impression I got is that when I presented these possibilities and these facilities, there has been a lot of interest from the Sentinel side, for instance. I had an expression of interest for collaboration last week, for instance. And so I think there is a potential there. And of course, we will have to analyze all the steps to get these, and of course there will be some problems, but I think the final objective should be come up with 4 sites, 3 sites of and then a number of years, so people can see that this weird community taking spectral measurements is actually producing some results, and some products are available. So we should, hyperspectral has got a potential for calibration and validation, and we should use a tool to simulate bands, and of course to calculate indices, and maybe we should also explain why these indices are important. Although I think that the community, I mean, it's quite clear in the community, but if this is needed, we can do this. So I think that the point made by Jose is really important. We should just use it as a dissemination tool and as a sort of advertisement as well for future collaborations for our network.
Sorry to speak a lot, but I wanted to add something because ICOS is maybe not clear for everybody. When I say that ICOS should only do something robust and defensible, I'm talking about what is going to be ICOS stamped product, if you propose it as a variable. Of course, ICOS will be a network of flux station. It's a European research infrastructure. It's available for anybody to set up his own FPA project of 3 million, try free approach in Boreal, Mediterranean stuff, and do what you want on a free. Just take care a lot what is ICOS products that have to enter in a global strategy, and after there will be this site available for making science and do whatever you want to develop this stuff.
Yeah, just to give you an example, last week I was talking with Michael Berger from the European Space Agency, and he was telling me that now there are these tenders to set up these mission performance centers, which are going to use existing facilities for calibration and validation of the Sentinel missions. I think it's out. The tender is out for Sentinel-1. I'm not sure about Sentinel-2 and 3. Maybe, do you have more information about this, Jose?
Yes, actually, this will be. This was related to the point I made before because they are looking for calibration sites. That's clear. Now for Sentinel-1 because it's the first one, but they will be for the rest. The question is these sites, and for instance, tomorrow you will visit the site in Cáceres. From the remote sensing point of view, if you want to do some field measurements over there, this is not a proper site for validation because it's too complex. If any kind of measurement you do over there, if you want to compare what you measure on the field with the satellites, I will not go to this site in Cáceres for the calibration because it's too complex. So one of the issues, this was really my point, is that it's obvious that linking the activities of Eurospec and ICOS is obvious, but you said before that you want to choose 3 sites. I will be careful because we know that for calibration and validation, there are sites which are very, very good, very appropriate, and there are sites which are extremely difficult, simply for technical reasons. It's not that the site is bad, it's simply the fact that because of the geometrical structure of the site, the link between field measurements at the scale of centimeters and the satellite will be very difficult, and we will not get nothing out of this because simply the comparison is too difficult. Now, if you choose other sites which are more homogeneous or more where the comparison is more easy, then you can really make the case. And we have to be careful not to bias just to sites which are good and this kind. But, but on the other hand, it will be risky to take as an example one of the sites which is extremely difficult. And one of the criticisms is that for calibration and validation of the satellites, the FluxNet sites are usually located in complex areas, complex vegetation areas, where structure, some cases, is an issue and things like that. And this is why some people in remote sensing think that this is not the good calibration site. But I think it's a question of looking at the proper site. I think the site in Cáceres is probably not the best one for calibration validation just because of the heterogeneity. But there are other sites in ICOS that can be used for that. And the point is just for calibration and validation, you try to look for very simple sites which are really homogeneous. Some of them are not appropriate and can be used for other things, but not for calibration validation. I know this discussion with Michael Berger for Sentinels, and this is exactly the point. This is why if we bias the discussion towards let's use these ICO sites for calibration validation, there will be people from the other side that will say no, please, we don't want.
Yeah, there will be a subset of these level 1 sites who are good for calibration and validation. But I was just mentioning these 3 sites because maybe we have, let's say, hyperspectral continuous measurements in a couple of sites or 3 sites for now. And of course, we have much more for multispectral. So it was just an exercise. But in the near future, of course, the sites for calibration and validation will have to be selected basically by the remote sensing community together with Eurospec or this networking.
Yeah, but I wanted to add something because this discussion on simple and complex stuff is also in the eddy governance community since a long time, because you have to select flat terrain. So, for example, in the mountain, you select one flat terrain, and the flat terrain is 1% of the Pyrenees. And then how you can upscale that to the reality of the Pyrenees. So I understand fully what Jose said, and I say if you make a new product, the first time you want to validate, you are going to avoid any complexity of the terrain. But for me also, I have the problem when I heard that, and as modelers also told to us where we had very simple site in eddy covariance that, okay, I understand fully that to start you don't want to cope with multiple problems because you are not going to have nothing clear of your study. But I think for me, for I understand the overall if remote sensing is getting so much interest, it's because you have global results, you have universal results. So if the final game, at one point, maybe not the first calibration and validation point, you want to start with complex system, but at one point you will need to validate it also on complex system. So it's a matter of hierarchy.
Yeah, I just want to add something, not because we are working in this site, but just to give you an example of how these complex sites are quite necessary in the validation process of these global products. We have been working in burn area mapping for a while, and you know that there is a MODIS product that has been developed for burn area mapping. We have tested this MODIS product in the European Mediterranean area several times, and we always get bad results here because this product has not been calibrated nor validated in Mediterranean areas. But Mediterranean is quite important in a global scale also. It's a quite complex ecosystem. We know that, we have to deal with that, but we have to include it in the global analysis. So I think we should also think about that in order to improve these global products.
Yeah, I totally agree with you. The question is that if I want to sell that in ESA, for instance, I know there will be people saying that just don't complicate the story from the very beginning, then we'll discard this discussion. For instance, if we want to complex side, then we will probably need to apply the approach of Jean-Luc with using the models and doing that very sophisticated kind of things. But on the other side, from the point of view of, I think the discussion right now is what kind of instruments you have to install on the site and how you want to install these instruments. Now, forget about validation or remote sensing and things like that. If I had to characterize what is the situation in this area in Cáceres, for instance, I would say, okay, I will need to put at least 3 or 5 different instruments, one looking at the crown of the tree, another one looking at the soil, another one looking somewhere around, and maybe some scanning system doing some looking at the surroundings. So it's not impossible, but simply I will need to have at least 2, 3, or maybe 4 different instruments to get something which is really meaningful, telling me what is going on there. While if I go to other sites, maybe with just a simple camera, with just few bands, I can tell most of the things which are going on the site. But I think that at the end, yes, we need to go for all sites, including the complex sites, including the topographically complex sites. But for that, we will need additional instruments and much more complex setups. This is what I was suggesting, that first we choose areas which are rather simple, with just a few cameras. We can characterize what is going on, but we need to characterize the site, meaning what is going on really in terms of dynamics, structure, variability in pigments or color or something. And then I will not start, for practical reasons, with the most complex one, given the status of the whole activity. But of course, I agree with you that at the end we should go for the complex sites. And
but for example, you can propose whatever. You can say, for example, currently the methodology for assessing forest, because of the structure, it's very difficult to have something standardized. So at the first step, because we control more the stuff, we are going just to make the crop site of ICOS, and then you have a more simple setup. You can start from that, learn from that. I mean, all of the arguments that are made by a lot of people are true, just to find a way to have good strategy with that.
The problem I see is that we need to come to something, a specific conclusion in order to make some progress. Because I think what we are saying is basically everybody will agree, because this is general point. But I think if we want to make the case, we have to install something like the hyperspectral sensor that you were mentioning. There are already some instruments which are, and actually we are doing that already. So it's not perfect sensor, but still what they provide can be good enough. Particularly you do some calibration from time to time to make sure that the system is working properly. And you can show this data to the community to demonstrate that there is information there. It's not just noise. There is something telling you what is going on. And it's not redundant information over the flashes. Because if we are saying it's basically, well, this is the story that the flash is already telling me, then there is nothing new. So why we need an additional instrument? So we have to say that the new instrument is telling something which is not exactly the flux. It's telling something about the physiology of the canopy or something. And then I think we can make the case. If we make the case for three stations, then later on you can expand the network for others. I'm trying to be optimistic. It's not trying to.
Yeah, I was just mentioning these 3 sites because probably we have hyperspectral data for 3 sites for now, and I don't know even if all of these 3 sites are happy to share data, but I think they will be probably happy just to upload this data and make them visible. So and then we will have to discuss more about data policy, but so would you start from crops in these for a possible proposal, an idea for calibration validation? Probably crops, I guess.
There are already some experiments going on, and I think, for instance, in the States there is one well-known site run by Anatoly Gitelson, you probably know.
Nebraska.
Yes, which is a very well-known site, and basically he's using already this idea of continuous measurements. So it's not, we are not inventing something new. I think for crops it's clear, because this is more easy. What is important here is to make the case for towers and to link with the fluxes, and because this will make more scientific. It's not just for calibration of satellites, because for calibration of satellites, as I said before, if this is only the case, it will be other sites probably which are more convenient than this for other reasons. But if you want to make the case, the scientific case for linking this to the flux towers, carbon cycle problems, and then I will go in this direction. But I think there is already examples showing that, for instance, for crops, this is working. And we know the example of Nebraska, and we have other places. But we have to make the case that we don't want just to do something which is in a very simple target, because this is something which is possible. It's not really a big scientific question. But the idea of linking to the towers and things like that, but it's something that can be done. It's simply just to see how we can arrange a setup that was really. I like the idea of the hyperspectral, because on the one hand you can simulate any band for the satellites. There is another technical argument, because for sensors with different bands, there is no correlation between the drifts of the different bands. So you have 2-3 bands. Mm-hmm. Each one of them can go wrong in different ways, and you don't know how. While for hyperspectral sensors, if something goes wrong, typically all the bands will go wrong at the same time, but still the spectra will look like. I like more the idea of hyperspectral sensors, and I think we can also make the case more for hyperspectral sensors than for. But yes, I mean, if we can, ideally, what we can do is to choose one side which is a rather simple crop, for instance, where you have a rather simple surface, together with a more complex area, so that you can make comparison between a simple case where for sure it will work, mm-hmm. and a more complex side where you can have more difficulties. But at least you can show that for the simple case, it's working very well. And for the more complex side, then of course you have more difficulties. But it's usually a good strategy to choose one side which is simple and one side is more complex.
Yeah, for ICOS we were going for hyperspectral for a number of reasons. Because the first reason is because it's a long-term infrastructure. So I think that in the meanwhile also there will be advances in the technology. So and considering the cost of multispectral versus hyperspectral, and considering that HYCOS has got some funding for this, we should definitely go for hyperspectral. The thing is, and this is another problem, we will have to talk about the setups on different ecosystem types. Because, okay, we have hyperspectral, but there's a lot of things to think about to standardize the setups. I mean, on conifer forests, we will have to take measurements with 25 degrees, and the height will be, I don't know, 10 meters above the canopy. And we will have to try to standardize as much as possible. And for crops, there will be another case. For complex ecosystems, maybe another case. So another challenging phase we will have to get into will be the protocols and in particular the setups when we will have to install the instruments, because there are technical issues involved in it. So there will be some work to be done in the next months, I think.
So Jose, when you are talking about simple sites or used for cal validation, you're talking about mainly croplands. Those are the ones that are being thought for forests which are really homogeneous. The idea is not to use for calibration validation a site where already the field measurements are very difficult. Yeah. Because, for example, the two examples that I have shown in my presentation regarding, it was a site in California that is pretty homogeneous. It's a almond and pistachio orchard, and all the trees are, line up really well. The spacing in between the trees and all of that. But for example, in there you have the complexity of irrigation, right? And each of these trees are irrigated at different times. There are also these trees are being clipped, right? So there are other complexities in there that, if I was to tell, which of the two, the one in California or Las Majadas was more complex, to try to, in this case, just validate kind of water content. Maybe, I don't know which one of the two I would choose, because, the ESA, the trees are not clipped, for example, that often. You can monitor better from year to year. There is no irrigation going on. Yeah, you have the cows that are, eating the grass and all of that. But it's, to me, a crop environment, is probably not as homogeneous or as simple as one could think.
This is exactly the discussion that if we talk about validation of specific variables, then the whole discussion is much more difficult, because that will depend, for instance, for canopy water content, there are some constraints, for leaf area index, there are other constraints. Here I think the discussion is, I want to put one optical sensor somewhere, measuring continuously something, and I want to put that somewhere where it makes sense. Because what we measure will tell you something that has some meaning. It's not just noise. And then it's not validation of retrievals of canopy water content. I'm talking about simply the fact that we want to take advantage of the fact that there are already some sites which are used for ICOs, for fluxes, and we want to add some instruments which are optical instruments installed over there. And there will be issues about field of view, the height of the sensor, and things like that. So I'm not talking about validation of products. It was exactly the point, that for validation of product, I will go somewhere else. But I think the discussion here is not validation of products. We can also add this additional thing that we may use, again, the same site also for validation of products. But this will be another discussion. But if we skip this last point, just talking about what is the optimal strategy so that we get the best we can from the tower side, and the tower people are happy having our instruments put over there because we get something that is meaningful. And I think the constraint will be mostly the field of view, the height at which you can put, because you need a tower which is at least 20 meters over the canopy or something. And there will be the kind of constraints. But I think given the network they have, we should be able to identify 3 sites where we can put something, and there will be some meaningful information coming out for this. Even reflectances. I think for the first step, we can stop our reflectance. Later on, we can even try to see if you can retrieve canopy water content from the reflectance and link the canopy water you get from the tower with the canopy water content you get from your actual measurements in the field and link that with MODIS. That will be very nice. But this will be for me like a second step. In the first step, you can stop already in reflectances. Yeah. And that will be one, because this is the risk I see, that if we try to go too ambitious, we may get to any place. So if we be realistic from the very beginning, it could happen that in a few months we get something which is meaningful and we can show to the outside community that is right, that really that makes sense. And those 3 sites need to be in Europe? Well, I see this Eurospec network will try to work mostly in Europe, I can imagine.
And also ICOS is European.
ICOS is Europe. Another discussion is, just because this meeting is with FluxNet, is if we can join some activities with the Americans. Because we are discussing quite a lot about potential cooperation with Americans in terms of different things. And even now there are discussions in terms of hyperspectral sensors, because we are trying to see if we can manage to get the new Averis in Europe again and have some flights like we did already 20 years ago with the first Averis. And there is several discussions about cooperation with that. So maybe we can try to see if we can do something together, because there is now an agreement between ESA and NASA for joint campaigns. And this was done for Cryosat, for the poles, but the agreement has been extended, and there is now the possibility of doing some activities together. And there is a framework for that. It's a high-level framework for this. So maybe there would be a possibility for that. But to be pragmatic, for long-term measurements, we can only rely on European sites, because any cooperation with sites somewhere else will not be funded under the ICOS or Eurospec scheme. So for the first time, I will rely only on European sites. But still the possibility of cooperation with North America and other places is still open. So maybe we can try also to see if there is some possible, at least for campaigns, it will be possible over the next few years. For intensive campaigns, not for long-term measurement, but for specific intensive campaigns, we are trying to do something together in this context.
Yeah, Jose, you're right that there's interest coming back to this in North America, or in the US anyway. Not so much Canada, because things are going downhill right now there, but in North America, the HISPRI effort is bringing a lot of attention to this community, or the kinds of things that we're discussing, like spectral libraries, as a working group on spectral libraries. And I think from participating in that group, I would say that the group has not yet really wrapped its mind around a lot of the issues that we've been discussing here, and the true potential for spectral libraries. I think it's taking a very narrow view of that's based on sort of the geological examples in the past, that thinks of these things as static. I think what's pretty clear is from this community is we can think of these things as very dynamic, and it's the dynamics that is of interest. So it's a different view of the fundamental data than I think the discussion that's currently going on. So I do think there's an opportunity, as you say, to work with, for the European community to work with North America. And I would add Australia to that right now, given the recent efforts and ongoing efforts there. So, what intrigues me is this idea of a few sites, this discussion of selecting some sites. I think that process could be very useful. The Flux community has the Marconi and the Latouille data sets, and those have been incredibly useful in terms of drawing some larger conclusions, ensuring data quality. It sort of set the bar, the standard for data quality, and I think that raises the quality of the data elsewhere, even for people who aren't participating. And I think we could talk about the same sort of thing, perhaps a vehicle for these metadata issues and these protocol issues and all of these issues that seem so challenging, can be working towards defining a set of sites that we could use for a similar kind, an analogous kind of effort, but focusing on the optical measurements. And I think that could really move this forward. And I like the idea of doing that within the European community, because I think of the funding issue, that makes sense. But I think there's also some opportunities to invite people elsewhere to consider being part of that. And that might be a really good way to start to move the discussion towards something larger than Europe, something larger than our own backyard, but something that's truly universal. So.
The reason why I mentioned this possibility that the new average sensor came to Europe is that actually most of the people I know that are working in hyperspectral now, these things originate from the flights that we have in 91 with average in Europe, flying almost in every country. There was a huge community created out of these flights. So if we repeat the exercise again, maybe flying in some of the sites that have been selected already for this activity, this will bring the community more active. But I agree that for long term, it's better to rely on the towers. But there is really a possibility in Europe because, we are building MMAP, and there's a number of activities that will go in the same direction. The other point I would like to make is that this discussion is also going for other cost actions, where we have the same discussions between remote sensing people, modelers, and FluxNet towers, but for the modeling community only. And I think if I will be running the towers, I will see, well, there are different communities coming to me asking for data. And so maybe at some point we will have to see if we can put the different elements together to get to something which is really robust. Because I think for every one of the pieces I see is not enough the story. For instance, we are trying to make the case between the optical measurements and the tower. Basically, the modeling community is not in our group here. It's not in the room today. But there is, well, not the full modeling community, I would say. But yeah, there are some people, of course. But there is also another meetings where there is mostly the modeling community, but there are not really people taking ground data. I think if we really join the two people together more closely, we can really make the case for the need for that, because there is really a need for validation data. We know that there is a lot of things in the models which are wrong, and even there is a very strong inconsistencies in the model, and they know that, but they say, well, but we need to get some validation data really to prove that this is really the case.
You mentioned some cost actions. Which cost actions are?
For instance, terabytes is one of them.
Terabytes, okay.
But the details vary, but the key issue is that there are different communities. If I would say, well, what is the common thing? Mm-hmm. There are different communities. There is a modeling community, the remote sensing community, the ground measurements community, and each one needs the other one to really make the full scientific case. But we are building the case from different point of views, and really at the end, if I would look from outside, the whole case is not really made properly. And if we really join the efforts together, we can really be much more stronger. Because I see the problem here is not to get to the situation they are now in Canada, where the whole thing has been closed. So we don't want to go to this point in Europe. So then for that, we need to join efforts from the different communities and say we need the towers, we need the optical measurements, we need the models, we need all the things together to really improve the knowledge of the carbon cycle and the overall dynamics of vegetation. And this is the message that should go to the high-level people.
I agree that a message like that is important, and I think a good example is for those of you who are at the Berkeley FluxNet Specnet meeting last year, this theme of measuring fluxes everywhere all the time was a theme that Dennis presented, and I think it kind of captures what we're talking about. You know, it's like the blind men and the elephant. You know, all the blind men are feeling the different parts of the elephant, and somebody's describing the trunk, somebody's describing the tail, somebody's describing the side. That's kind of how we are with our different techniques. We're each measuring a piece of the elephant, and we're saying we're measuring the elephant, but really it's that combination of what we do that measures the elephant. And the elephant can be defined different ways, but for example, measuring carbon everywhere all the time. So you could argue to really understand the carbon cycle universally for all of the world, the biological aspects of the carbon cycle, you really need to have all these blind men working together. And so I do think that can be a compelling argument. I'm not sure we've made that compelling enough, but I think it's an idea that's starting to grow. And I think it's important to make that argument, you know, whether it's that one or another one. But so I think we were hoping Loris was going to conclude this discussion.
No, I was just going to mention also regarding the possibility to join the overseas efforts and the European efforts. We've been trying in the last years to meet up on a semi-continuous basis every 1 year or 2 years. And I think it's quite important, this cooperation, also because there's a sort of mutual stimulation. I don't know how to how to define this. I see that the very common sentence in Europe is, but the Americans are doing this, and in the same time, the Americans say yes, but we should move forward because the Europeans are doing this, and I think it's a kind of, you know, positive cooperation, and it's not a competition, it's just a cooperation. So coming back to this a positive interaction, I was thinking that Eurospec is going to finish in 18 months. So by the end of 2013, we will organize a big compared to this, let's say, conference with probably 100 people invited, and it could be a joint conference together with Specnet and Fluxnet, inviting maybe some of the coordinators of ICOS. And this would happen by the end of 2013, more or less. So we will think about a location, basically, and we could start thinking about this conference and what the objective of this conference could be, according to what we've been talking about. So this is something I wanted to say before we conclude this session, like and this meeting, Specnet-Eurospec, that the cooperation now maybe could continue, and of course it will continue on a continuous basis, but the next meeting could be the final meeting of Eurospec, and also to this context, I hope we will find a way to continue this networking, and also to find further funding. So we will try in a framework of a new cost action, or we will try, as we tried, to present some FP7 proposals with these objectives. So these 20 months are going to be spent also thinking about continuity. Pilar, how is the time?
It's okay, the building closed at 8, so we have plenty of time.
Okay.
The dinner is at 9, so...
Do you have pillows available? Pillows?
I don't think so, but we can think about that.
So coming back to this data sharing platform, are you happy with this discussion?
Right, I should think that probably what I take from this is small is beautiful, and it's better to have a little demonstration tool that shows the potential to people instead of trying to do the monster thing that does all the sites at once, and then it would definitely fail. So what I think is, I did a little doodling here what this thing could look like, and it shouldn't be too much effort to just pull the information. If I get of a few sample test sites the spectral information plus the metadata, in a way the summer school data was presented, then the effort to put this in a database is really, you know, negligible. So the main issue is to nicely present it, and to, I like this idea of extracting data from ICOS about the tower sites, for example, because this is some information we don't have to put into our database. The only thing I expect that would link the ICOS to our set is a common identifier, like a unique location name or identifier. Something like this will most likely exist. Yeah, and then if, as in this summer school dataset, I thought this was really nice to have some biophysical parameters being calculated, and then we could select a subset of those which might be of interest to the community and just have them presented in this interface. So that could be.
So are you talking about ancillary data? Like when you talk about biophysical parameters to be
I like to think about this as higher level products of spectral information. So like if you extract what an NDVI or PRI or whatever you are able to extract, then this would be such a biophysical parameter, estimated biophysical parameter.
Okay.
You right? I'm talking about estimates.
Yeah. Okay. Yeah, if in one side there is a model, you can just apply the model and give some products.
Correct.
Basically. Any other observation?
Well, I can see Andreas has written the plan on his piece of paper. It's right there. So I think we're covered, but
We'll see.
no, seriously, you know, it is hard to solve these things in a large group, but this is a very helpful discussion, and I think some of what has to happen has to happen in small groups, you know, following up on meetings like this, and I think there'll be some progress from this meeting. I guess the useful thing, I think, at that point is really to engage this community, have a good method, a good mechanism for continuous feedback. So as things happen, you know, making sure that that information gets back to the community, and the feedback and contributions from the community come back into any data process, you know, any data development, database, data management tools, the process of developing that. I think it's going to need some ongoing feedback to make sure it's useful. I think where these efforts have failed in the past, and I described something I called a failure today, the geochronos. You know, great ideas, but you know, without that really ongoing engagement, you know, everything from reviewing it to being part of the effort to putting data into it to taking data out of it to running models from those data, all those steps are really where we learn, you know, what's useful and what's not, what's working and what's not, and you know, we have to break it to make it work, sort of. I think there's going to be a fair amount of that given the nature of the discussion about the complexity of the issues that come up in these, you know, these meetings.
Mm-hmm. I I think this possibility of using the infrastructure as a calibration validation reference could be one of the themes of the working group 4 dedicated to upscaling, which will take place in Innsbruck by the end of October, if I'm 29th, 30th. So, Jose, if you are willing to continue your precious collaboration, keep in mind this meeting, which will be focused on remote sensing and the upscaling, basically, upscaling our observations. So keep in contact with Enrico. By the end of October is 29, 30 in Innsbruck.
Okay. I would like also to invite all of you to join this action, and if you are interested in the present discussion and to continue this discussion, you can just write an email to Loris, and you will be contacted and included in the discussion about protocols and also data sharing. And I think during these days we present a lot of nice point of discussion that fit very well with our final our topics, and I think the most important now it's important to start to discuss deeply and finally to try to provide this protocol and also to provide some specification for people that is not deeply involved in optical sampling, and that is in fact one of our objective, and we will spend a lot of time in the next future to keep in touch with ICOS, because for us it's a really good opportunity, and we will continue the collaboration with Specnet. Andreas will go to the lab of John in August, and by the short-term missions initiative, we can continue to collaborate with different laboratories and also to collaborate with other really important international laboratories. And if you are interested to join this initiative, you can, or if you have a young research PhD that can be interested in this activity, the short-term mission is a really great opportunity for exchange knowledge and experience. And this meeting was really fruitful, and I would like thanks Pilar and Javier and other people that I don't know personally for the really good organization and to host this meeting here in Madrid. I would like also thanks John that come here and offer his help also in the organization, in drafting the agenda, and all of you that spend your time here discussing with us.
Is there
Do
any
you-
announcement for tomorrow?
Okay.
Then we have the social dinner at Café Gijón at 9, so we will meet there. Then tomorrow we will leave from the main entrance of CCHS at 8, so the bus will be in the main entrance of the building. And we will give you some information tomorrow about the route that we will follow from here to the Majadas Tower and then to Monfragüe National Park. I have seen the weather prediction, and tomorrow will be better. So the maximum temperature is 30 degrees, so it's quite good. It will be not so good with the sun, but I think it will be a good opportunity to continue with some discussions during the travel. We have more or less 3 hours from here to the tower, so I hope we enjoy with the field trip. I'm sure we'll do it. And I just want to thank you again to everybody for coming. Thank you especially to the survivors. And I hope to see you again in the next COS meeting. And we for sure continue with this fruitful discussion. It would give us some open questions that we hopefully will close soon. Thank you.
So who's going to close this never-ending session?
Well, I'll just add to this. From my perspective, I want to thank you for organizing the meeting, and I think it's been a great group, and it's a journey that we're on together. And I guess my selfish interest, or maybe it's selfless, I'm not sure, is to try and encourage everyone to sort of continue to think about how what you're doing here in Europe, which I think is very useful and important, can help and contribute to the larger effort. So I just would like to invite everyone who's interested, please take a look at the Specnet website. We're working on a lot of things there, and so there'll be some changes. One of them is better site registration, so that when you register, it's automatically done. We're working on that right now. Also, you can join the mailing list if you're not. We don't send out a lot of emails, so you're not going to get a bunch of junk mail, but occasionally we send out something, and it'd be nice to, if you're interested to being on that list, to know who you are. And anyway, I guess I'm looking forward to going back to North America and telling everyone all the wonderful things that the Europeans are doing, and I hope that does some good.
Is it me? Yes. Okay. Yes, I would like to thank you for coming. I see there are a lot of new contributions also to this network, and the Spanish members, of Eurospec are quite active, I have to admit. And what to say, I'm really looking forward to see this AmpSpec system, and I think the discussion will go on tomorrow. Thank you again. It's over.